Okay, so again, I am Nicole Gauthier. I am the plant pathologist for fruit crops. So today we're going to talk about integrating disease management solutions. So when we integrate other approaches besides fungicides, they all come together in what we love to call IPM. So IPM means integrated pest management, and that's how we integrate all of the tools that we have in our toolbox to manage pests, and in my case, disease. So we can even call this session integrated disease management. And we're using both cultural practices and fungicides to manage disease. So not just fungicides, and that's really the key. Also, with an IPM program, we're always trying to look for softer approaches or safer approaches first before we resort to fungicides. So again, I like to call those cultural practices. Any IPM will fit into any agricultural or horticultural program, whether you're greenhouse or field, whether you're organic or conventional, or anything in between, hydroponics, fields, artificial media, IPM fits. And so it's not just reserved for one small niche within our fruit industry. Also, IPM fits any crop. So perennial crops, annual crops, agronomic row crops, or small greenhouse in your backyard. So IPM fits everywhere. And today I'm going to talk about it in that very general sense. So first, and for those of you who know me, you know we've got to talk about very fundamental disease concepts. So plant disease 101. Plant diseases are the symptoms, okay? The symptom is how the plant reacts. That's your wilt, that's your rot, that's your spot, or your stem canker. That's the disease. It's the plant's reaction to whatever the infection is. Signs, or the actual pathogen, is the causal agent. So disease can be caused by fungi, bacteria, water molds. Those are like your pythiums and phytophthora. They're fungus-like, but they're not true fungi. Viruses and nematodes. Those are all very different pathogens. So we talk about disease as if it's one thing, but it's really not. So disease can be caused by one of many different types of pathogens. And even within those subcategories, there are a lot of different types of fungi. For example, there are soil-borne fungi, and there are those that infect flowers, those infect leaves, and those in fruit. So this is a very wide, very broad area. So again, I'm generalizing today. All of our plant pathogens, though, are microscopic. So we tend to look at symptoms and say, what is this? So I get a lot of emails, what is this? And I usually say, it has to come to the diagnostic lab. I don't really know. And that's because we need, at minimum, microscopes to identify these plant pathogens. They're very small. So the role of disease, or the cycle of disease, is important when we think about IPM and when we think about disease management. So let's kind of walk through what might be happening in your field or in your greenhouse. The first thing that has to happen is the pathogen has got to be introduced into the field, introduced into the greenhouse, introduced into that planting. So introduction can come by the way of spores blowing in from a neighboring field, or in the case of cucurbit downy mildew, they blow in every year from the south. Introduction can be an infected transplant that you purchase from maybe not so reputable plug producer, and you put it into your field. So introduction has to happen. If the pathogen's not there, you cannot have disease. Okay, so we start with the pathogen being introduced onto a site, then it has to infect your plant. In order to infect a plant, the plant must be susceptible, and the environmental conditions must be optimal for that pathogen. So susceptible plants, we can talk about some of our pathogens are really host specific. So they have preferences to a genus. Cucurbit downy mildew will only infect cucurbits and not your tomatoes, for example. Or we can talk about Resistant cultivars, and I'll talk about that a little bit later. So we do have some resistance within cultivars. And then after a pathogen infects, it's going to reproduce. And so it's going to spread and it reproduces. Fungi produce spores, bacteria produce cells, etc. So it's going to spread and reproduce, and those that inoculum, that new inoculum, will create new infections. And so you've kind of got this repeating cycle, if you will. And then those propagules, whatever those are, will be disseminated, okay? Disseminated within the same plant, within the same field, or they can go even further. Those fungal spores sometimes can blow around in the air. They can blow for long distances. Other times we disseminate them with soil-borne pathogens, with soil under our shoes, used media, dirty tools, non-sanitized greenhouse. So dissemination can occur by people, by a lot of insects that will transmit viruses, and then by just things like wind and rain, wind-driven rain splash. And at the end of it all, at the end of our season, remember we're in Kentucky, we have winter, is overwintering. And some of our pathogens are more cool season, so they'll over summer when it gets really hot and dry. But it's a survival stage. It's a pause in the life cycle of a pathogen where it will survive and wait for the next crop. And for annual crops, that's really important. I know we're talking fruit today. Most of our fruit crops in Kentucky are perennial crops, but an overwintering pathogen. So once a pathogen is introduced and establishes on a site, it's often going to overwinter, and it's going to wait until next year until you put the new crop in. So at that point, that's where we kind of tell you you've got it established at your site, and it will be there for years to come. And we talk a lot about site history, and that's where that comes in. All right, so putting all of that together, we talk about disease and how bad it can be. The first thing we think about is fungicides. And fungicides are great, right? Especially our new modern fungicides, they can really be powerful tools. And it's the first thing we often think about when we think about disease management. But fungicides are not our only solution to disease management. And especially in an integrated program, they're one of many tools in that toolbox. And I know we produce a lot of resources when it comes to fungicides. We've got spray guides, lots of spray guides. We've got efficacy guides for those fungicides. So probably a lot of times it appears that we may be putting those fungicides at the very top. And even within the fungicide category, we have different types of fungicides and different ways to use them. But remember, IPM is integrating all of our management tools. So today I want to talk about cultural practices, not fungicides. I think Dr. Besson's going to talk about insecticides in an IPM program. So we're not contradicting each other. We're just each presenting a small piece of this very large, complex picture. All right, so back to fungicides. Back to cultural practices, not fungicides. Cultural practices are anything you do physically to manage disease or to manipulate a pathogen's life cycle that is different from applying fungicides. I've got some examples here on the screen: proper site selection, resistant cultivar, sanitation, those types of things. And those are all cultural practices that we use. So let's talk about some of those and how they fit into an IPM program. I'll start with site selection. The right site gives your plant a better chance of being healthy and robust and tolerant to a lot of diseases and disease pressure. So when we talk about site selection, we can talk about the general site. So think about a field. Is it well drained? What's the surface drainage? What's the internal drainage? And from a disease standpoint, that's going to be maybe conducive or not for a soil-borne pathogen, especially like your water molds like Pythium and Phytophthora. So a good site that has good drainage and good soil texture is our first step, right? So before we plant the first thing, I know some of our attendees today are thinking about growing fruit or vegetables commercially. So this is the first thing you think about. What does my site look like? Also look around your site. or you're near the woods or the forest. If that's the case, there may be some pathogens that affect forest trees. For example, cedar apple rust on apple, its alternate host is the cedar tree, right? So if you're near a fence line or a forested area, you've got an alternate host, and you've got you create a higher risk for that disease. So site selection can, again, is not just the physical site, but what's nearby. And then finally, what about the history of that site? What was there before? We think about apple replant disease. So what has built up in that site previously, and how will that affect your crop that's going in? So disease history or site history, surrounding areas, and then of course, just the site itself, some of the physical characteristics. Next, we have tillage. Again, I understand that in fruit production, most of our fruit crops are perennial crops. Okay, so I understand that, but strawberries. So we have both annual and perennial strawberries, and even our perennial strawberries don't stay in the ground very long. So between crops, can we till? And in a sustainable ag program or an organic program, generally we try not to disturb the soil, right? We try to preserve the soil. But if there's a soil-borne pathogen or something that has built up, often tillage will help us bury those propagules. And a lot of times when we bury spores or different survival structures, they'll decompose when they're deeper in the soil. So sometimes 2 inches or 6 inches can make a lot of difference if we bury those propagules. So in the case of an outbreak or a history of a really persistent or tough disease in a site, tillage may be the answer. So think about that, or strawberries, so building up those raised beds. So tillage can really play a part, especially for us in strawberry. And then, of course, when it comes to site prep, tillage may really work in some of those cases too. And I'm a pathologist, so I'm talking specifically about outbreaks of really persistent soil-borne pathogens, or those that overwinter in debris, that if you bury that debris, it could break it down much more efficiently. Okay, next, resistant cultivars. I kind of touched on that a little bit earlier. So resistant cultivars, a cultivar is a cultivated variety. And so a resistant cultivar will be within a group, okay? So powdery mildew resistance or downy mildew resistant or tolerant cultivars. And sometimes, we use the word resistant pretty loosely sometimes. Be careful that that resistance can mean totally resistant, or there can be some resistance, so some tolerance. And resistance may be, again, complete immunity, or it could be maybe a delayed effect, or maybe the disease doesn't get as severe or doesn't cause as many yield losses. So resistance can mean a lot of things. Also, when we talk about resistance, it's not just cultivars, it can sometimes be the genus itself. Grapes, for example, we have multiple different species of grapes. So there can be some resistance across there. So susceptibilities and resistance are both worth considerations. So think about that. I know for apple, we have a listing. We have a fact sheet for disease resistance in apples. And in our Midwest Fruit Growers Guide, there's a lot of information on grape cultivars. Okay, next, rotations. Crop rotation is very common in annual crops. Again, we're dealing with a lot of perennial crops, but strawberries is one. This one fits the bill here very well. Crop rotations are really great, in particular when we have soil-borne pathogens involved. So if we rotate a site, if there is a soil-borne pathogen, our rotational crop would be something that's tolerant or resistant. So we're trying to outpace the life cycle of that pathogen. So crop rotations are very important. Strawberries are often rotated into vegetable programs, but really think about rotations, how you can add rotation to your program. We also have things, and I said this a little bit, we're not going to go in really deep on like apple replant disease. Those are often soil-borne pathogens as well as some nutritional issues. So we don't recommend planting apple immediately behind apple. So if an orchard is being renovated, for example. So think about what a rotation would look like in something with such a long-lived perennial crop. Next, plant spacing. So as we set plants out, the spacing will determine air circulation. And in the plant disease world, air circulation will reduce canopy humidity and it will increase airflow, drying leaves off more quickly and reducing humidity. And we didn't talk about this today. We talked about this in last year's webinar, but environmental conditions are the driving force behind disease development and disease severity often. So 70% humidity and usually moderate temperatures, which is like what we prefer as humans, are often optimal conditions for plant pathogens. So if we can reduce the canopy humidity, increase airflow, dry leaves off more quickly in the mornings, we've lowered that amount of that free water that's required for pathogens to infect and to reproduce. So really important, a good airflow, the direction, the orientation of your rows, making sure that as much air you can get, the better. And for those of you who are in a mountainous region, I know that's even harder, but really think about how you can space plants and orient plants to get the best airflow possible. And next is diagnostics. What do you have? We must know what disease you have, what pathogen is out there in order for us to make recommendations and for us to manage it. So we do a little bit less monitoring and scouting in the disease world. We usually focus on a preventative approach. But if you have a problem, it's very important to understand what disease you have, how widespread it is, where it is, upper canopy, lower canopy, a specific cultivar or a particular end of the orchard, for example. So to know that and to be able to watch it, what's happening, communicating that with your county agent, and your county agent will work with specialists as needed, is the way we can actually understand what's going on. So that will help us use things like pruning, sanitation, those types of things to help manage. We have to really understand what's going on. And for those of you who don't know, Kentucky residents can utilize our plant disease diagnostic lab. For any disease diagnostics, you will go through your county agent. And if you are a commercial grower in particular, I highly recommend that you understand every disease that's in your orchard. So send those samples in, we'll get it on record, you'll get that name, and then we can help by sharing some of our fact sheets and some more information. Our fact sheets have information about life cycle and optimal conditions and temperatures, those kinds of things. And then you can start putting these pieces together and using cultural practices to help reduce the risk of disease in your orchard. All right, so finally, sanitation. Sanitation is my all-time favorite topic. Sanitation simply means clean. Clean it up, keep things clean, keep everything clean. From your greenhouse floors to if you're reusing containers in your greenhouse. Sanitation means washing your equipment and washing your tools, keeping mud from under your shoes, from tracking disease from one field plot to the next. Sanitation, again, it means clean. Clean up after the season. Get rid of or rogue infected plants. Those we will tell you if you should rogue or not. Okay, if it's a really serious disease or one that cannot be managed with any other way, we'll often recommend roguing. So if a plant has to be rogued, get it out sooner rather than later. Any fallen fruit, any infected fruit, that's got to go. We call that clean picking most of the time. So picking your fruit in two different buckets, one of them with your clean and healthy fruit and another one with the culls to get them out of there. Because again, back to our overwintering, Plant pathogens can overwinter in debris, in fallen fruit, in branches, in weeds. If you're pruning, don't throw your clippings on the ground. That allows overwintering or survival of those pathogens. So keep everything clean as possible, just like you clean your house, just like we expect our hospitals and doctors' offices to be clean to prevent transmission. Think about it in the very same way with your orchard. And last but not least, we come to fungicides. Fungicides are part of an IPM program. We can't dismiss fungicides. Some diseases, some crops don't require fungicides. Some growers choose to use organic fungicides or softer products, but they still fall under the umbrella of fungicides. Sometimes we do need fungicides. If a pathogen is more persistent than our cultural practices can handle, we often do need some type of fungicide. Now, fungicides must be tailored specifically to the pathogen that is causing disease. So a fungicide isn't just a blanket term. So we need that diagnostic piece in order to choose the right fungicide. Then we've got timing. We must apply fungicides at the correct time. And that is, again, determined by what that pathogen is and the life cycle of that pathogen. And of course, fungicides are most important in the Southeast where it's so rainy. We have a lot more rain. We have very high humidity, and that is a higher risk for disease. So whereas some of our counterparts from other states, they might not be spraying for something, it might warrant spray here in Kentucky. In particular, grapes, peaches, and apples probably require the most fungicides of any of our fruit crops because they're susceptible to so many more diseases, and our climate is just conducive for infection and disease spread. Okay, and last but not least, we need to think about post-harvest disease. So I always talk about production. We talk about what's in the field, but don't forget about handling and storage. Any disease in the field will pretty much move itself into the cooler, okay? Fruit rots in particular will move themselves into the cooler, and then disease has just transferred. So never put diseased fruit or vegetables in the cooler in storage, intending to use them later, because they will sporulate and they will spread. A lot of damaged fruit moving into the cooler, any kind of wound is an open door for a lot of infections. So any of your post-harvest diseases can move from fruit to fruit in the cooler, especially through wounds. So be very careful of sun scald or physical wounds because those will attract any opportunistic pathogen. An opportunistic pathogen is one that says, oh, hey, it's an open door, I'm going in. Okay, also think about the conditions within your cooler, right? Managing that humidity, managing those temperatures, making sure there are not puddles on the floor or dripping from your condenser, and having that free water there. So keeping your cooler clean and efficient. And then, of course, there's sanitation. We talked about sanitation in the orchard. There's sanitation in the cooler. Keep your cooler clean, clean it often, because pathogens will survive. They have propagules that will let them stick around and hang out, waiting for another batch of that all-you-can-eat buffet. And then, of course, there are infections that have not developed into disease yet. And that's when your customer is going to have that peach in the fridge that will later develop disease. So just because you don't see disease doesn't mean that there's not infection that will translate into the customer's refrigerator or counter. And so managing disease in the field and being very careful about sanitation in the cooler, avoiding wounds, will keep the best produce coming out of your storage and into your customers' hands. Okay, With that, I'm going to wrap up. We have a lot of disease literature or disease management literature on our website, and that URL is plantpathology.ca.uky.edu. So plant pathology is my department, of course. CA means College of Agriculture. .uky.edu. And then we have a lot of social media, Facebook, Twitter, and then also we have a newsletter, Kentucky Pest News. So I can put any of these in the chat at the end of this hour, or you can just screenshot here watching. But this is a really good opportunity to see what your risks are when. So we tell you what your threats are at different times of year or under different weather conditions or environmental conditions. So we post a lot of timely articles. So please feel free to join us in any of these social media and subscribe to Kentucky Pest News for up-to-date information.